Hello everyone, this is Mr. O'Leary again with another conversions practice. So the last time we did this, we talked about the dozen. We talked about how 1 dozen is equal to 12, and then we massed out or calculated 12 grapes and came up with a mass of 12 grapes. So, and then we also did a mass of 12 bananas, and we were able to convert between grams to dozen to number of to dozen to mass. And we knew you couldn't go directly from grams to dozen because, well, grams to number of, because a dozen grapes and a dozen bananas have different masses. They're not equal yet. Well, when we convert them to dozen, now they were equal, talking the same language, and we could convert them to how many of them there are from there. The mole is no different. One mole has 6.02 times 10 to the 23rd atoms, and 1 mole has whatever the molar mass. And if we look at the periodic table, we know hydrogen is 1.008 grams, or 1 mole. Boron is 10.81 grams in 1 mole, and xenon is 131.29 grams in 1 mole. And you notice as we go down here, as we add protons and neutrons, the mass goes up. So the molar mass goes up, and it's a lot more massive for the same number of atoms. And it kind of makes sense, hopefully. So if we were to look at this, just to take a step back for a second, the mole was, it came up, it was an Italian physicist, mathematician named Amedeo Avogadro. He lived from 1776, he died in 1856, and like a lot of times in science, it wasn't until after his death that he was proven right. He made huge contributions. Don't feel too bad for him. He lived a very good life, as far as I could tell. Look up some information. It's pretty interesting to see how it goes. But anyway, if we were to take a step back and we were to look at, let's say we had 1 mole of lead. So 1 mole of Pb. And I wanted to know how many, we analyzed the problem, and I wanted to know how many grams that was. Well, if we look over here, we can set our equality. 1 mole of Pb is equal to what? How do we figure that out? Well, we look at our trusty periodic table. If I can get my mouse to work. Lead is down here. It's 207.2 grams, and 1 is the molar mass, and it's 1 mole. So 207.2 grams. So 1 mole has how many grams? So we analyze the problem. We have 1 mole of lead, and we need to know the grams. We have the problem is we want to go from moles to grams. Can we go directly from moles to grams? We can go moles to atoms, or a number of. Then we can go to moles to mass. So we can. So we can go directly there, and the preceding goes to the denominator. So we have mole in the denominator and grams in the numerator. And 1 mole has how many grams? 207.2. So we solve it by going, I have 1 mole of lead times our equality, which is 1 mole under 207.2 grams. And that equals, obviously, 1 times 207.2 grams of Pb, or lead. And we can look through here, and we notice our mole cancel, and we are left with 207.2. That was an email, sorry guys. Now we evaluate this answer, and now we don't always have to rewrite everything to evaluate it, but I want to evaluate it. I want to look at this answer. Does this answer make sense? Well, yeah. It's easy to see. 1 mole is equal to 207.2, and I didn't need to do all this because we know it. But guess what? If you set this up, it makes things like this. It makes your life easier in the future. So much easier. So now if we have 1 mole of lead, we know how much mass it is. So let's talk about 1 mole. How many number of do I have? How many atoms do I have in 1 mole of lead? So if I analyze the problem, let's change that back to blue. I have 1 mole of lead, and I want to go to atoms of Pb. Well, the problem is I have moles, and I want to go to atoms. And the preceding goes in the denominator, so I put mole in the denominator, atoms in the numerator. And I know 1 mole is equal to 6.02 times 10 to the 23rd. Correct? So we solve this by having 1 mole times our equality, which is 1 mole under our 6.02 times 10 to the 23rd atoms of lead, Pb. And that equals 1 times 6.02 times 10 to the 23rd divided by 1. And that simply just equals 6.02 times 10 to the 23rd atoms of lead. And we box that in. Now, that's a horrible box. But anyway, if we look, we have to do our dimensional analysis. Just make sure our units match up. So we have mole divided by mole. That's 1. And we're left with atoms. And that's what we wanted. So that's great. Our molar conversions are no more difficult than that. So if we were to look here and I wanted to say, let's try this again. And I wanted to say, I analyze the problem and I'm asking you for, I wanted to know 1,000. I have 1,000 grams of lead and I want to know how many atoms that is. Well, our problem is I have grams and I want to go to what? I want to go to atoms. Can I go directly to atoms? No, I cannot. I have to go through the mole. So preceding goes here, so we go grams in the denominator, and I need moles in the numerator. And then I multiply that by my next equality, which is moles in the preceding goes in the denominator. And then what do I want? I want atoms. So atoms needs to go in the numerator. So we have 1 mole of lead has how many grams? It was 207.2. One of you let me know if I was wrong on that. I didn't look. Well, let's look. And you can't let me know because you're watching a video. Lead is 207.2, so we were correct. So 1 mole has how many atoms? Well, it doesn't matter what it is. If 1 mole we're talking about, it has a 6.02 times 10 to the 23rd atoms in it. So that could give us our answer. So now we solve it. We solve it by going to 207.2. Sorry, somebody should have stopped me. We have 1,000 grams of lead times our first equality, which is 1 mole of lead over 207.2 grams, times our next equality, which is 1 mole under 6.02 times 10 to the 23rd. And that equals what? So we just take out our trusty calculator, and it is 1,000 divided by, well, let's do it the other way. 1,000, I like to do it out. 1,000 times 6.02 times 10 to the 23rd. And then we'll do our division, 207.2. And that equals what? Well, how many sig figs do we have? 1, 2, 3, 4. So 1, 2, 3, 4, so it would be what? 2.095, and I forgot what the exponent was, times 10 to the 24th. Times 10 to the 24th atoms of Pb. And we box that in. Now we evaluate our answer. Does that make sense? Well, I have 4 significant figures here, so I have 4 significant figures here. And if we do a little dimensional analysis, so we have a mole here, gram here, we are left with atoms. And I should have wrote atoms in there, I just couldn't fit it, sorry guys. So we evaluated this answer, and it looks to be correct. Good job. So, and that's how you can go. You can go directly back the other way. So let's say I had I analyze my problem. My problem I'm asking is I have 1,000 atoms. Does everybody know why I put a period here? It shows it's all significant, all 4 digits. So I have 1,000 atoms of Pb, and I want to know how many grams this is. Grams of Pb. Well, our problem is we have atoms, and we need to go to grams. Can I go directly to grams? No. I have to go through the mole. So preceding goes in the denominator, so I have atoms in the denominator. mole in the numerator, and then when I get to moles, I have to go through the mole highway, so I have to go through the mole. So mole goes in the denominator, and then we have grams in the numerator. So 1 mole of anything has how many atoms? That would be 6.02 times 10 to the 23rd. And 1 mole of lead has how many grams? And that would be 207.2. We looked it up on the periodic table. So now we have our setup here. Now all of it's done. All the chemistry's done. Now we just have to do basic math. So we solve this by doing 1,000 atoms of lead times our first equality, which is 1 mole of Pb over 6.02 times 10 to the 23rd. Atoms of lead, multiply that by our second equality, which is 207.2 grams over 1 mole of lead. And we end up with what? Let's see what we have. It should be a very small number. Sorry about that. Let's move this over here. So we have 1,000 times 1 times 207.2 divided by 6.02 times 10 to the 23rd. And that is equal to, well, we have 4 sig figs, so 1, 2, 3, 4. 4 in here, 3.441, well, 3.442 times 10 to the negative 19. So this is equal to 3.442 times 10 to the negative 17 atoms. That's a very small number. Let's just check that number again. 3.442 times 10 to the negative 19. Should have told me, guys. Let me write that all over again because that's a real number. So 3.442 times 10 to the negative 19 atoms of lead. Box that in. Well, we should have evaluated our answer before we boxed it in, but let's see, take a look. So we have here, so we have atoms in the denominator here, atoms here, we have mole here, and we're left with grams. Oh, we evaluated it, and I did it wrong again. So let's look here. It should be grams. We should be talking about grams. So that's why you always evaluate. It's very easy to get confused, okay? And so we are going to grams of Pb. And then we box it in, and there we go. Our dimensional analysis, let's go back to that again. So we have atoms here, we have atoms here, we have mole here, we have mole here. We're left with grams. We have grams. 1,000 atoms, 1 mole of atoms is equal to what? 6.02 times 10 to the 23rd. So if we have 1,000 atoms, that's going to be really small comparably to this number. So it makes sense. So there you go. You should be able to convert between atoms to moles, moles to grams, and grams to atoms or moles or anything. You just need to know you need to go through them all. Have a good day, everybody. Stay safe, and hopefully see you, well, when everybody's safe.